GitLab is the faster path from idea to software. It's more than a code repository. It's one workflow that brings development, security, and operations teams together. No walls, no endless feedback loops. Use GitLab end-to-end or integrate it with the tools you love. And it lets you eliminate the rest to help reduce costs and boost productivity at the same time without trade-offs. With GitLab, teams can build software faster, automate software delivery, shorten cycle times, and increase developer productivity. And security is built in, not bolted on. Scan for vulnerabilities with every code push, automatically. It's the entire development process, all in the same place where everyone works. Because we're on this path together. The path from idea to collaboration to higher performing teams. With one comprehensive, innovation-driving, fast and secure DevSecOps platform. Software faster. GitLab.
Okay, let's go ahead and jump in. Thanks again for joining us today. We're excited to have you. Today we're going through DevSecOps and compliance. So looking forward to going through that content. Before I pass it over to, to my colleague Rashid, we are going to just be going through a couple of housekeeping items. First off, this webinar is being recorded, so you can look for that recording to come through here in the next day or so. Additionally, if you have any questions that come up throughout, please feel free to put those in the Q&A portion of Zoom. We look forward to getting those questions answered for you. And with that, I will pass it over to Rashid.
All right, thank you. Hi, everyone. My name is Rashid Babatunde. I'm a customer success engineer here on the Scale team at GitLab. So as Taylor mentioned, our session today is going to be focused around DevSecOps and compliance within GitLab. We're going to discuss how development and security teams can work together in a single tool, allowing for proactive security or shifting left. The goal of today's conversation is to provide you with an overview of what GitLab offers from a security and compliance perspective, how scan results integrate seamlessly with merge requests as part of the development workflow, and how to use security dashboards to manage vulnerabilities. We encourage you to reach out in the chat if you have any specific questions or anything related to a particular use case, or if there are any capabilities you'd like to learn more about. So with that, I'll just go ahead and get started here. So we're going to start with an overview of GitLab security and compliance capabilities and discuss how application security fits into the software development lifecycle. From there, we'll go on through how developers, security teams, and compliance professionals can take advantage of these tools and create a DevSecOps workflow that fits the unique requirements of your organization. Along the way, feel free to drop any questions in the chat, and one of my incredible colleagues here will be able to respond as I'm presenting. With that, let's go ahead and get started. We're going to look at GitLab as a DevSecOps tool. Historically, there have been two primary ways to address DevOps. Here in the first example, we dubbed it the dirt road. Organizations have siloed incompatible tools and processes with manual handoffs and a lot of redundancy. And as a result, not a lot of collaboration, consistency, or compliance. The paved road side on the right here, it's going to be an attempt to make the best of a bad situation, limiting the chaos of the previous scenario by limiting the number of tools, then building integrations among them to achieve some sort of workflow automation and consistency. It's certainly closer to the end goal of DevOps, but with those integrations, it comes with kind of a brittle state. The tools themselves are often still only marginally compatible, and managing all of that digital duct tape becomes the responsibility of your team members who could otherwise be creating better value. At GitLab, we see a multitude of customers use our platform effectively to manage all aspects of their software development. And from this vantage point, we observe the core attributes and capabilities of successful organizations that adopt to and implement an effective application security strategy without compromising desired speed and outcomes of their digital transformation objectives. We can also identify failed attempts at the shift left principle. Specific characteristics of these failed programs can include things like misaligned business and DevOps governance objectives, lack of vision or strategic roadmap to reduce risk. There's tool sprawl, shadow IT, lack of a formal secure software development lifecycle, unclear remediation roles and responsibilities, program budgets that are not aligned with risk objectives. So as we move on and continue, we'll elaborate on some of those ways that GitLab can be used to transform your organization from that sequential DevOps approach to more concurrent DevOps. So let's dive into what this means for development and security teams specifically. So as we all know, changes in the code base are accelerating. Along with your development changes, you also have an increasing number of open source tools, APIs, and microservices, all with changes that need to be tracked. Because of this, it's not really realistic anymore to rely on traditional methods for scanning your applications. In order to ensure a robust security posture that meets the needs of the current moment, you must empower your developers with security tools so security can be incorporated into their CI builds and automation. You can't leave it all to the security team to handle it anymore because of that scale. So today, there are too many vectors of attacks for software vulnerabilities. Security is a team sport, and so it's everyone's responsibility at this point. We as GitLab want to lead a new era where security is baked into the software development lifecycle. With a single application that's purpose-built, we're able to enhance this modern software library or software factory rather. The value of the shift left approach that we're recommending organizations take is that with this workflow, both development and security are going to be able to work more efficiently and effectively. That leads to cost savings and reduced risk. So to kind of illustrate this a little more, let's talk about the kind of traditional approach to application security for a moment. As a developer, in a traditional process, you might push code to your repository, maybe run your CI, even use a merge request or a pull request to kick off a deployment pipeline, which then might hit a test environment. And at that point, you may be saying to your QA or security teams, okay, so here's a new version of the application that's available for scanning. And this all happens at the end of the process after you, as a developer, have most likely moved on to your next task. With this scanning occurring so late in the lifecycle, any vulnerabilities found are going to take more resources to resolve because your developers are not empowered to fix vulnerabilities when they're most aware of them. And that's in the context of their work. Now, when security is integrated into the software development lifecycle from the very beginning, you're treating security like any other code flaw and enabling better collaboration between developers and security teams. You have a single source of truth between dev and security by integrating security into the normal dev workflow. We can scan before the code is committed to the stable branch and also maintain a list of approvers to ensure security of the main branch. Security vulnerabilities are reported directly to the accountable developer and are viewed within the same pipeline workflow. The vulnerability can either be dismissed or an issue can be created in the same place, which makes tracking much easier for both developers and security teams. We've found over many years that the best way to scale application security is by enabling development with continuous security. And this level of integration is only possible because GitLab is a single application for the entire software development lifecycle. So here you'll see, essentially in a traditional sequential DevOps approach, each function, as we saw previously, is running within a silo, using their own tools that have been selected, like a bring your own kind of DevOps scenario. They may be locally optimized, but this includes multiple handoffs, tool friction, as every team hands over to the next team. Organizations wanting to be faster and more efficient are adopting the GitLab concurrent DevOps model. This approach offers a way to get development, security, and operations teams to work together. At the same time, they're able to collaborate on a single pane of glass, so to speak, and design, build, test, deliver, and monitor the code changes. DevSecOps at GitLab integrates security best practices into the DevOps workflow, allowing 100% of code to be scanned on commit, enabling adaptable automation and remediation, all executed through GitLab CI. Security issues are reported directly in the pipelines and merge requests, and security teams can view dashboards to manage all vulnerabilities separately and easily. And this is with zero context switching from anyone involved. To move to kind of go further into that, this essentially allows teams to easily move from that sequential DevOps pattern to a concurrent DevOps, which in turn, it allows them to work together with seamless collaboration, empower themselves to action security issues as they come. And it empowers them to essentially embed security from the code commit level, ensure full accountability, measure software at a more granular level, and reduce cost throughout the process. This is just an overview of what's provided, but we will dive into each one shortly. It is also important to note that integrating security into the software development process also leads to cost savings, as I alluded in the previous slide. As you're all aware, when you develop software, most of the time you're building on your previous work. So the longer you're waiting to fix bugs and vulnerabilities, the more code is affected. And this results in higher costs for development, mainly due to the longer duration for that resolution. Additionally, with the context switching, trying to recall what was done weeks, sometimes months after a release can consume a lot of cycles. After an application is released into production, it costs 30x more essentially to fix security flaws than it does while in design, and almost 15 times more than in dev. In this image, you'll see that the different cost thresholds here as they increase with each stage of the cycle. So from coding, integration testing, system testing up to production, you'll see that it actually goes up in cost. So this is something to keep in mind as we're kind of going through this presentation here to give you an idea of how concurrent DevOps helps to reduce these costs and essentially provide more efficiency for your team. With GitLab, you have a comprehensive level of support for your entire software development lifecycle. Within the secure stage, we offer functionality such as static application security testing, container scanning, dependency scanning, license compliance, secrets detection, and dynamic application security testing, just to name a few. With these features in place, you can, there are some additional scanning capabilities outlined on this slide, but our scans can be built within your merge request so that way developers can iterate on their code and collaborate with one another. They can also collaborate with the application security teams and empower themselves to remediate these vulnerabilities before they make it into production. Your security team, they essentially will have more agency and insight into the process as well, and can require approvals and enforce scans in line with your organization's security and compliance policies. Additionally, these same security teams have visibility into your organizational risk through our security dashboard, where you can view summaries of security findings and generated vulnerability reports in one dashboard view. Next, we'll go briefly over some of those scanners that are available in GitLab, and then we'll talk about how workflows look from the perspective of a developer. And then we'll also go on to the same type of perspective from the security and compliance teams as well. So the available security scanners. Static application security testing, or SAST, is designed to analyze application support code, bytecode and binaries for coding and design conditions. And these are indicative of any kind of security vulnerabilities. SAST solutions analyze an application from the inside out in a non-running state. It shows vulnerabilities before deployment and in a single report on the MR widget. Then we have dependency scanning. Applications often consist of third-party components, mostly open source, and the software dependencies are often the largest attack surface. With GitLab dependency scanning, they analyze external dependencies, for example, libraries like Ruby gems. They show vulnerability dependencies to update and offer any suggested solutions to automate and simplify remediation. This helps you automatically find those security vulnerabilities in your dependencies while you're developing and testing your applications to keep you aware if you accidentally introduce a dependency that's known to be vulnerable. GitLab is able to detect secrets and credentials unintentionally pushed into the repository. For example, an API key that allows write access to third-party deployment environments that can be detected through these secrets detection algorithms. This check is performed by an analyzer during the SAST job and runs regardless of the programming language of your app. The results are available in the report, and there's no need to change the CI/CD configuration file in order to use secrets detection. GitLab detects a variety of common secrets by default, but you can also customize the secret detection patterns using custom rule sets to add or exclude rules as shown in that bottom image there. So here you can see that we can add different regex to the descriptions here and actually customize those according to your environment. Most applications rely on external components to implement specific functions, preventing the need to code everything from scratch every time. This is why third-party libraries are so common. With these third-party libraries being fetched directly by package management tools such as Ruby gems or NPM, this approach requires that you ensure that the licenses for external components are compatible with your application and that there's no conflict that could lead to possible legal issues. License compliance automatically collects all licenses used by your dependencies and displays new ones in the merge request widget before they land in your main branch. So with the license compliance, you could definitely do multiple kind of functions there as far as like manually allowing or denying those licenses. Again, additional languages and package managers are supported experimentally. Results are all available in a single report. Container scanning. Docker and other container systems include a signing infrastructure allowing administrators to sign container images to prevent untrusted containers from being deployed. However, it's not necessarily the case that a trusted signed container is secure to run because vulnerabilities may be discovered in some of the software in the container after it has been signed. Container scanning does static analysis on those Docker images for vulnerabilities in the application environment. It also analyzes image contents against public vulnerability databases and uses the open source tool Trivy to scan any type of Docker image. So moving on to DAST, which is the dynamic application security testing. Even after running static checks on your code, there is a possible risk such as cross-site scripting or broken authentication flaws when deploying your application. So GitLab DAST uses an open source tool to analyze running web applications for known runtime vulnerabilities. By default, it performs passive scanning, but can be configured to perform more active scans where it attacks your applications and provides an extensive security report. It's very useful when used in conjunction with review apps. The key aspect of DAST is that it helps you find vulnerabilities in your running web applications while you're still developing and testing them. So that way you can resolve the risk before any kind of deployment. Infrastructure as code scanning. For infrastructure as code scanning, we're directionally choosing Kix, which is an open source scanner by Checkmarx. It's very extensible and covers all the core IAC that we wanted, from Kubernetes to CloudFormation, Ansible to Terraform. The types of rules that Kix looks for are syntax errors, access control, encryption, insecure configurations, networking and firewall rules, and best practices like not having a password expiration policy in place. And finally, GitLab allows you to add fuzz testing to your pipelines as part of the CI/CD workflow. Fuzzing is the act of inputting unexpected or random data to measure the response or stability of your application. By using fuzz testing, you can discover unknown bugs, errors, or potential security issues that other QA processes may miss, and that could lead to vulnerabilities if not resolved. We have two types of fuzz testing today. As you see here, we have a coverage guided and API fuzz testing. We recommend that if you use fuzz testing, do so in addition to the other GitLab security scanners and in your own test processes, and always run tests against a staging environment or review app and not production. So as an overview of the GitLab security and the compliance scanners, we went over the SAST, the static application security testing, which again detects vulnerabilities in source code, such as SQL injections and cross-site scripting. We went over dependency scanning. These detect known vulnerabilities in libraries or components and refers to the different CVEs. Secrets detection, that detects credentials, secrets, passwords, and source code and prevents sensitive information leakage. License compliance, searches for approved and disallowed licenses defined by custom policies. Container scanning detects known vulnerabilities in container images, such as Heartbleed or shell shock. Infrastructure is code scanning, which scans the IAC configuration files, Terraform, Ansible, CloudFormation, and so on and so forth, for known vulnerabilities. And then we have coverage guided fuzz, which detects unexpected behaviors at program method level by passing arguments as white box testing. Then we see the DAST, dynamic application security testing, which analyzes your running web application for runtime vulnerabilities, leveraging the review app. And then we end with the web API fuzz, which detects unexpected behaviors of running web applications by generating random requests to the web APIs. While each of these features are available at the ultimate tier, please note at this time, the premium tier does have access to the SaaS scanners, container scanning, secrets detection, and IAC scanning. Now let's talk about some of the ways a developer can use some of these tools as part of their workflow. There's a lot of talk in the industry about shifting left, but what does that actually mean? Shift left is an approach that moves testing and security to earlier in the software development lifecycle. That means moving these processes as close as possible to the developer. The key to GitLab's approach is scanning the code at the point, the commit point, before the code changes and ever leaves the developer's hands, and before those code changes are mingled with others. When security is integrated into the software development lifecycle from the beginning, you're treating security like any other code flaw that you may find and enabling better collaboration and between the dev and sec teams within the merge request itself as part of the review. This creates a single source of truth between the teams while security is integrated in the normal dev workflow. This is powerful because it provides real-time feedback to the developer about vulnerabilities in their code changes while still working the code and enables them to easily resolve those issues. They can now resolve security flaws before the code hits production, and before any other teams even get involved. So this graphic here kind of shows a life cycle of development and security that incorporates the shift left principle. Once a commit is made, security testing runs in the pipeline, and with security vulnerabilities reported directly to the accountable developer, they can be viewed within the same pipeline workflow, and developers can either dismiss vulnerabilities or create issues to work them until the code is ready on every change that's been made in real time. Any vulnerabilities that are shown within the pipeline as part of the natural flow and within the information contained as the MR is running, help the developer remediate them. With the review app, developers can see and test working applications, and GitLab can scan the review app so that everything can be tested and verified before merging the master. With this approach, we can scan before code is committed to stable branches and also maintain a list of approvers to ensure the security of the main branch. We found that the best way to scale application security is by enabling development with continuous security. And this is only possible in this workflow because GitLab is a single application for the entire software development workflow. All of the scans are automated within CI pipeline out of the box. And that's all through a simple include template line. And that's within the GitLab-CI YAML file. This promotes shifting left because it makes it easy to integrate security into your workflows and allows you to remediate security vulnerabilities earlier. And because GitLab is a single application, we can leverage the review app, a fully functioning app used to test the changes made to the code. And that way we can run the dynamic application security testing, DAST, before the code ever leaves the developer's hands. And that's before the code's merged. So when we talk about enabling developers to address these security findings, what does that look like in practice? We just saw what the scanning looks like in the context of a pipeline. And now, I'm going to show you what it looks like in the merge request itself. Here, we have a specific CI/CD pipeline that successfully ran on a feature branch that has security and license compliance scanners configured. From this view, you can see a summary of the specific pipeline that ran. Let me see. Yeah, you can see a summary of the specific pipeline that ran. You can also see the approve button. So along with that, there's a dropdown to show the list of available approvers. And also shown is a short version summary of the results for each of those scanners, where you can actually see the 24 new and 4 dismissed vulnerabilities here in the source branch. The license compliance scanner, also, you see that it's also detected 2 new licenses here. So this just gives you an idea of kind of what that looks like within an actual merge request. From here, you can view the full report and expand those results within the pipeline. So then developers, in this case, can decide what action to take. What happens is one option here is to create an issue for this finding and either address it right away or in a future release. The other option would be to dismiss the vulnerability with a comment specifying why, such as false positive or an accepted risk. And to reiterate some of the benefits of this approach, every piece of code is tested upon commit without incremental cost. The developer can now essentially remediate while they're still working on the code or easily create an issue with one click. The dashboard for the security team is essentially a roll-up of vulnerabilities remaining that the developer did not resolve on their own. And those vulnerabilities can be efficiently captured as a byproduct of software development. Finally, having one single tool to handle all of this reduces, mainly the cost over the approach, and it reduces the cost over that approach of buying and integrating and maintaining point solutions. Additionally, developers also have access to integrated training resources. This integration capability uses the vulnerability information to get a link to learning resources that educate developers on finding and fixing that particular security concern. This basically provides developers with trusted guidance that they can use to resolve the vulnerability with confidence. It's also a highly effective way to retain the knowledge, mainly because with bite-sized coding challenges, that gives developers targeted hands-on skills in building within the vulnerability and helps them to resolve it. Additionally, with the contextual learning presenting in manageable chunks, continually reinforces good, secure coding patterns from a trusted source and not just enabling a patch. Having the training resources readily available also reduces the time gap between relearning and the application of knowledge, ensuring a lasting engagement and retention. And finally, this approach to vulnerability management helps developers grow their muscle memory to recognize security issues while they code, and that eliminates common vulnerabilities from the start of software creation. GitLab also provides resources to help guide developers in remediating vulnerabilities. When available, will provide a suggested solution as well as links to any relevant information. We also offer auto remediation for dependency and container scanning findings. You can resolve with a merge request where you can automatically implement the suggested solution, or you can manually download and apply the suggested patch. Here, you also have the option to dismiss the vulnerability and add a comment as to why. So next, we'll go over the experience of the security team. Security dashboards provide an overview of the security vulnerabilities over time, and you can use them to understand the status of your security, the security find and fix vulnerabilities affecting the default branch. It provides you visibility into how all current security issues are affecting a branch and allows you to make decisions about about priority. So you can focus on remediation efforts on the most, basically the most important vulnerabilities and easily manage them. It's important to know that security scans are performed every time the branch is updated. So if the default branch is updated infrequently, scans are run infrequently, and the information on the security dashboard can become outdated as new vulnerabilities are discovered. To ensure information on the security dashboard is regularly updated, and if the default branch isn't updated frequently, we recommend configuring a scheduled pipeline to run a daily security scan, which will update the information displayed on the security dashboard, regardless of how often the default branch is actually updated. These reports can be found at several different levels to provide you exactly the information you need. At any pipelines page, you can select the security tab. You can select the security tab to see the vulnerabilities found in that branch of the project that the pipeline just ran against. At the project level, you can see all vulnerabilities introduced over the past year within that specific project. And so you see here, we have the different status here of all the different vulnerabilities found throughout this 1 year span here. This allows direct security team level or CISO type of roles to immediately, have visibility into the group level security posture. And that way they can quickly understand any at-risk projects with security grades. At the group level, you can see all vulnerabilities found in a group and the subgroups and projects under it. They're able to see burn down charts of vulnerabilities over time, and for any given project, they can see those grades as well. These types of high-level trends and metrics provide you with insight and data to support better decision-making and vulnerability triage. And here at the instance level, which looks similar to the group level, you can see all vulnerabilities found across all groups, subgroups, and projects in GitLab. and you can do so by selecting which projects you want to include in the report. So it's very flexible, in order to get the exact information you want, even if the projects you're interested in are in different groups. In GitLab, security teams are enabled to participate in the vulnerability management process in a number of different ways. To illustrate what the vulnerability triage and resolution process can look like, let's walk through an example workflow. Everything starts as an issue at GitLab. So from an issue, a developer can open a merge request and commit code. And at that point, on every commit, the code is scanned for vulnerabilities. If a new vulnerability is detected due to the scan result policy, security group approval is required to proceed. If the vulnerability is legitimate, the security approver leaves a comment on the merge request to merge changes in resolution. The merge request is then passed back to the developer to make those new commits. If the vulnerability is a false positive, the security team member dismisses the vulnerability and approves the MR, allowing for the code to be merged. If no vulnerability was detected, the approval process from security is not necessary, and then the code can then actually be merged in. After the code is merged into main, it's scanned for live vulnerabilities. If a vulnerability is still detected in production and it's a false positive, the security team sets the vulnerability record to dismissed. If it is a legitimate and actionable vulnerability, the security team sets the record status to confirmed and creates an issue from that vulnerability. The development team can then action the issue by creating a merge request, restarting the process again. So the security team can also use vulnerability reports, which provide an overview of all the security vulnerabilities from scans of the default branch within groups and projects. You can drill down into a vulnerability for detailed information, the originating project and the files, as well as the metadata to analyze that risk. Then you can also take action on these vulnerabilities by creating an issue or dismissing them. Additionally, if you click into a vulnerability, each one can be triaged and tracked as a single source of truth. Vulnerabilities are persistent across scanner runs. That reduces duplicates, improving tracking and visibility. And this enables the ability to report on group and project vulnerability trends over time. When it comes to separation of duties, security teams have a number of controls available in GitLab, such as enforcing when security scans are run, which we'll talk about more in a moment, as well as the ability to set scan result policies, which essentially create approval rules and a criteria to enforce behavior after a scan runs in line with your organization's requirements. For example, you could set a scan result policy that requires approval from the security team for all high or critical vulnerabilities found after a particular scan runs. To get more granular, you could set a scan result policy that says something along the lines of, if any scanner finds a newly detected critical vulnerability in an open merge request targeting the master branch, then require 2 approvals from any member of the application security team. Approvals in GitLab have a lot of flexibility, so that way you can really customize those to meet the needs of your organization and workflow. GitLab offers visibility into your security risks via what we call a security dashboard. This allows either essentially kind of like director levels of security or CISO type roles, immediate visibility into that group level security posture. So it offers you the holistic ability to understand and manage your security risk across your entire organization. These types of high-level trends and metrics provide that insight to help support decision-making and vulnerability triage. So now we'll be looking at the compliance experience. Compliance framework pipelines allow you to define a compliance pipeline in a separate repository that can be enforced at the group level. You can use compliance pipelines to lock down your pipelines and ensure teams are running the right jobs in the right order, as well as force mandatory jobs. Next, we'll also go ahead and talk about a pretty important topic that's very much on the top of mind for many of our customers right now, and that's the software bill of materials, or SBOM. As I'm sure you're all aware, an SBOM is a nested inventory or a list of ingredients that make up software components. In addition to the components themselves, SBOMs include critical information about libraries, tools, and processes used to develop, build, and deploy a software artifact. In GitLab, you can use our dependency scanner to generate an SBOM. You'll get a dependency list, which breaks down all of the different dependencies and licenses that are being used in your application to help you understand the holes in your application and meet compliance requirements. Now, there are a lot of tools out there that can generate an SBOM, but then the question becomes, what are you going to do with it? What's unique to GitLab is that we make it really easy to not only generate those SBOMs, but also take action based on the results. So you can quickly export the SBOM into a Cyclone DX format that can be shared externally, which again, a lot of other tools can do, but the real value is in the visibility and context that GitLab provides this information in, so you can quickly take action on critical vulnerabilities in your application. You're able to easily view which dependencies have vulnerabilities, drill down into the vulnerability, see if there's a suggested solution, create an issue, put it into the right developer workflow, remediate it, and then move on from there. So this isn't just about generating a bill of materials, which is great, but it's also having an actionable SBOM. When it comes to auditing, you may need to satisfy an organizational requirement to prove things such as separation of duties. With GitLab, it can give you information such as who took an action, what that action was, who authorized the action, and from where and how long did it last. And what other gaps, that may possibly exist as well can all be found by analyzing the project audit events. GitLab can optionally stream audit events to external logging tools as well, such as Splunk. With GitLab's compliance reporting functionality, you can verify that all code contributions meet your org's security and compliance requirements. With the compliance violation report, you're able to see a high level of MR activity for all projects in the group and the severity for each compliance violation. An example of compliance violation could be a merge request being merged with fewer than 2 approvers, or an author approving their own merge request. GitLab also has a chain of custody report that gives a 1-month trailing window of all commits to a project under a group, which gives insight into information such as commit SHAs, author or SHA, the author, the date committed, etc. Finally, that compliance framework report shows all the compliance frameworks that are applied to a group, which we'll talk about in a little bit. So we'll move into the Q&A portion. Let's see here.
Awesome. Thanks, Rashid. And yeah, we had a few questions come through, so I'll pose those here and go through them. The first one: how can I integrate GitLab security scanners into our CI/CD pipeline?
As far as integration of the security scanners in a quick, easy way, definitely recommend checking out Auto DevOps. In fact, I'll open up one of the doc pages here. With Auto DevOps, it allows you to basically take advantage of these features using templates. So this is the Auto DevOps page here. It does go over the different stages, the different features. It's also highly customizable. So that's definitely something I recommend taking a look at. is the auto DevOps templates that we have available with GitLab. GitLab develops GitLab using GitLab, and these are the templates that we're using for net new features and products.
Awesome. Next one here. How can I get more hands-on experience with implementing these features?
As far as getting more hands-on experience, I definitely recommend checking out our webinars. Here, I'll actually drop this in here as well. So our webinar schedule here, we have a lot of different upcoming webinars that will provide you with access to workshops that you'll actually get hands-on experience by following along with the instructor. You can actually set up compliance pipelines and things along those lines, just to give you, more experience with using GitLab. So I definitely recommend that. For self-paced courses and certification, recommend checking out our Level Up, GitLab Level Up. Through GitLab Level Up, you can actually, again, just do self-paced courses and also micro courses that'll help you level up in GitLab and also gain certification that you can show as well.
Very cool. Next one. What compliance standards and frameworks are supported by GitLab, and how can we ensure our projects align with them?
As far as different compliance standards and frameworks, GitLab knows that continuous compliance is a key factor in ensuring kind of efficiency and security of your software development lifecycle. So different compliance frameworks and pipelines, compliance frameworks and pipelines will allow you to adhere to those various standards from SOC 2 to HIPAA, GDPR to ISO. I can provide a couple resources as well that kind of pertain to the different compliance features. The compliance features documentation actually will kind of walk through what we've talked about today, but in more detail to help you with planning out your roadmap as it pertains to implementing these different compliance features. Again, that's something that a lot of our enterprise customers are using to actually adhere to these standards. We also have a blog post that kind of goes over the different compliance standards and meeting regulatory standards with GitLab compliance and security policy management. This is a very good document as well. It kind of breaks down kind of how that relates within GitLab and how you can take advantage of these different features.
Awesome. And then the last one I see here, are there AI features in GitLab?
For sure. GitLab is an AI-powered platform. We do have, I will go ahead and put in what's called GitLab Duo. So with GitLab Duo, it is AI-powered workflows with various features going from code suggestions, suggested reviewers, value stream forecasting, vulnerability summaries, test generation, code review summaries. There's a lot of different features that are, rolling out. Definitely something you should definitely take a look at the roadmap on. We do publish our roadmaps publicly. And there's also a pretty good blog post that I'll drop here entitled The Role of AI in DevOps. Here we go. And so this particular solution here will give you just a breakdown of kind of what AI is, how it relates within our tools, and what are the benefits of using AI in DevOps. Again, yeah, that's definitely something that's a pretty big focus for GitLab, and we're continually rolling that out.
Awesome. Thanks, Rashid. And thank you, everyone, for joining us today. We appreciate you taking some time. It was great going through DevSecOps and compliance with all of you. As we mentioned at the beginning, the recording and deck will be sent out here in the next day or so you can look forward to that. And with that, we'll wrap up today's session. Thanks, everybody.
Thank you.